We discussed what is sustainability earlier, basically making sure your design is safe and sound for today as well as for future. And we discussed some examples, and then we moved on to the pillars of sustainability: environmental, economic, and social. And we looked at some examples. Then we talked about environmental sustainability, where you are basically focusing on these three main factors. And then the economic sustainability, okay, where basically you have to look for the life cycle. You have to make sure the product is durable, project or product is durable and can last for longer time and will be cheaper during the life cycle. Okay. And life cycle means from design till the end of the use. Okay, so when the building is no longer usable, the road is no longer usable, that is the end of the life cycle. Okay, now we move on to social sustainability. So we discuss environmental and economic. And did we discuss this? Okay, I think we didn't do. In social sustainability, the first thing is health and safety of the people. So you have to make sure that anything which you do will not cause any harm to the public. Okay, and that also includes the people who are working on the project. So if you are using any harmful material which is dangerous to handle, okay, that is obviously not, you cannot do that. We talked about earlier about disposing the waste. So if you are disposing the waste in a way that it will be creating problems for the residents in the area, so you did your construction, now the construction is finished, now you have some waste left on the site, so you have to dispose it in a proper way. Okay, you cannot just leave it, okay, because that will cause problems to the people in that area. uh, so one more example I can give is the handling of the cement. Okay, so or the mixing of the concrete or handling of the concrete. So with these materials, the handling needs to be you need to be careful about handling these materials because people who are handling them, cement is basically made up of chemicals. So if they are handling them for longer periods of time with raw hands without any gloves or something, it can be harmful. Similarly, uh, uh, with a lot of these materials, aggregates and cement, you create a lot of dust pollution. Okay, you talked about different types of pollution. So you create a lot of dust pollution during the construction at your site. Now this can harm the people who are living near the site, and it can also harm the people who are working on the site. So you have to contain it in a way that it does not spread to the other people in the area, and you also have to make sure that people who are on the site are taking precautions to be safe from that type of pollution. So they are wearing masks, they are wearing gloves, and so on and so forth. Okay, so public health and safety is a major requirement, and it is a non-negotiable requirement. Okay, it's a non-negotiable requirement. You cannot say I will save my cost, okay, or I will make the building durable if I use this material or if I use this method, so I will finish the project faster. So I am fulfilling maybe the economic responsibility, okay, but at the same time I'm endangering the health and safety. So whenever there's a dilemma like this, where you have cost saving, where you have durability, where you have strength, and on the other hand have health and safety, the health and safety will always take the preference. Okay, always health and safety will always be on your top priority. Okay, and then we have accessibility. Yeah, accessibility for the people. Now the construction, the design which we do is infrastructure. People will use it. You are designing a building, you are designing a road, a bridge, a pipeline, whatever is for the use of the general public. So in those cases, accessibility is a big issue. So if you are not making it accessible, that means those people cannot use that facility. For example, I gave the example last time as well. The building is in UOB. Okay, so you see outside the building, you will have stairs and you will have elevators and you will have ramps as well. So if you do not provide these alternatives, somebody on a wheelchair may not be able to access the building. Okay, so you are restricting their accessibility through your design. Okay, if somebody says, okay, I don't have anybody to push my wheelchair, or I still have problems, that's another thing. Okay, but you are providing them means through your design. Okay, something again which is very connected to the concept of accessibility is serving communities equitably. Now, what does it mean? In there are countries, Bahrain, alhamdulillah, we don't have this issue, or maybe I don't know. But in some other countries, for example, Pakistan or India, you will see settlements or housing areas which are completely different from each other. So you may have a housing area which is well managed, well established, you have everything proper, you have electricity, water, everything is available, and then you have other areas which are for low income communities. In those communities, you will see the roads are broken, the electricity and water pipelines are not well maintained, so they are getting connected, disconnected. Okay, so this is what they mean here. Okay, so when you provide basic necessities, we are talking about basic necessities. We are not saying that okay, every citizen must have a two-story villa and should be lavish and it should have all the facilities. No, we are talking about basic necessities and the things which come under infrastructure, the things which come under utilities. There's another word for it, which is called as utilities. I'm recording it on my own because when I record through the Teams, so I will upload on YouTube like I do with my other lectures. When I was doing it physical, I was recording it on my own and then I was uploading it on YouTube. So I will do the same thing. Okay, but on Teams, then it creates problem when I'm downloading. So that's why. So going back to the point, when you're talking about infrastructure, when you're talking about utilities, electricity, gas, and water, and roads, so these are basic utilities. Everybody has to use it. Health, education. So and we are involved in the design of all these things. Okay, so for example, in the ministries in Bahrain, many of the people who are high ranking are from civil engineering discipline. They are our graduates. Okay, I met a couple of them, maybe more than a couple of them actually. So I have met them in urban planning department and Ministry of Works and Ministry of Transportation. Okay, so these people do the planning as well. Okay, so it's not only about when it comes to me, I will see how can I make it equitable. No, maybe inshallah you will get to a position where you are planning for the entire Bahrain, maybe. Okay, so then you have to keep in mind that your planning should be such that you are serving the communities equitably. Okay, so you don't differentiate on the basis of income, for example. Okay, that this is low income area, so they have less right to utilities, and this is high income area, so they have more right to the utilities. Okay, or their roads should be better and their roads should be poorer. Okay, so we cannot do that. So this is part of social sustainability or social responsibility, that when you are providing the basic utilities, basic necessities, they should be equally divided. Okay, and then you should with your design, we talked about this earlier as well. In engineering, we are doing something to fulfill the needs or to improve the quality of life. Okay, so sometimes, okay, I need a house to live, yes, so that's a need. Okay, and in other cases I I need a road which has less traffic. Okay, so I can still drive on a road which has congestion, which has traffic jam. Okay, the road I will get to my point maybe after 10 minutes or 20 minutes or half an hour. But if the road is better, it will improve my quality of life. Okay, so there are things which you do to fulfill the need, and there are things which you do to improve the quality of life. So improving the quality of life is part of social responsibility of the civil engineers as well. So we are trying to protect the people, okay, considering their health and safety. We are trying to serve everyone fairly. That is part of accessibility and equitably, and we are trying to improve the daily life. Okay, so you have to ensure public safety, health, and accessibility by all members of society. Which members are normally or which members require special attention? Children, elderly people, persons with disabilities. Okay, these are the people, or these are the members of the society which will require a special attention from the civil engineers in their design. Okay, because obviously they need more facilities in order to use a project. Okay, I already gave the example of the wheelchair. Elderly people, we have a pedestrian signal, let's say. Okay, the elderly people will go slowly. Okay, so if the signal timing is according to a normal healthy young person who will cross the road in 5 seconds, then you are endangering these elderly people. Okay, so you have to keep in mind, and this is in the code, this is in the codes. So if you go to the signal design codes, you will find that, okay, if the normal person has a speed of 3 feet per second or 0.8 meter per second, then you have to design it for 0.6. Okay, to accommodate for these people, elderly people, and disabilities, people with disabilities, and so on and so forth. And children, the same thing. Okay, so you have to keep in mind that children will be with someone. They may not follow the same path. They may not know. Okay, I have to go. I have to cross the road straight line, or I have to be on this side of the road always, and so on and so forth. So you have to keep in mind these things as well. So you may have seen near the schools you can install barriers, so children who are on the side, they do not come onto the road by mistake, and so on and so forth. So these are the people who need special attention. I already mentioned the equitable thing. So for example, you're designing roads with safe pedestrian crossings. It has proper lighting, and the sidewalk improves safety. Okay, so you have proper sidewalk, which is paved, and it is smooth, it is leveled, and it has areas where you can go onto the sidewalk and come out of the sidewalk using a ramp with the wheelchair. Okay, so these things will ensure the social responsibility in the road design. Similarly, if you are doing it for water systems, okay, so you make sure that the water which is coming to the house is clean, is pure, okay, does not have any harmful elements in it. You have a drainage system which is reliable. Okay, now we had rains for since yesterday, and you can see many of the roads are completely underwater. Okay, you cannot use half the road because you cannot see the lane. Okay, so the drainage system must be reliable. Okay, means it will keep on working with different amounts of rain. In Bahrain, we know that I believe you already have felt that you have been living here, that the amount of rainfall has increased. Considered good, alhamdulillah. So the design need to be revised according to that. Okay, that's the thing. You have safe public spaces which will improve health and quality. Okay, the parks, for example, or if you're talking about a public transportation system, then safe bus stops. Okay, and so on and so forth. Okay, so public spaces mean people go there and have fun and they go and relax and so on. Okay, walking areas, we have walkways and jogging tracks and so on. So these must be made safe. Okay, safe from traffic, safe from any obstructions, okay, and so on and so forth. Okay, so when engineers perform their social responsibility, then communities, meaning we are talking about not a person, we are talking about the entire area, the entire country, that will also become safe, healthy, and comfortable. Okay, so through your design, you can change uh, the entire country basically. Okay, so some examples. I already gave the first example. Okay, so providing water systems to all communities, providing clean water to all communities. Okay, it will protect their health and it will prevent diseases. Okay, in buildings you add ramps, elevators, and other access options to so that people can access quite easily. Okay, so why we are talking about sustainability so much in case of civil engineering? We have been talking about it for last two lectures now. Okay, so one of the main items is in civil engineering, whatever we design has to be long lasting. Okay, so it means that if I take a wrong decision now, people will suffer for a longer time. Okay, people will suffer for a longer time, or uh, you have to redo it. Okay, and you can imagine if I'm designing something for 50 to 100 years, uh, if I have to do it multiple times, then the cost will be too much. Okay, when you go for a building, when you go for a house, there are, I believe, more than 90% of the people, they build one house in their whole lifetime, right? And there are many people like who are not even involved in any other construction. Okay, so construction is a very costly business. Okay, for people obviously governments do that because they are getting the funds from different sources, but for people, even for government funds are not to be wasted. You cannot say, okay, we will see if somebody has a problem, I will do the redesign, we will demolish it, we will make another one here. No, it doesn't work like this. Okay, so if you're doing it for somebody, a private client, he may not have funds to do it again. If you're doing it for government, then you know they don't want to waste their funds. Okay, another thing is, if you don't take care of these things at the time of design, okay, then what you are doing is, and later on you have to do it. This is what we call as being proactive, oh sorry, being reactive. Okay, so what we are going for is the proactive approach. Okay, now can somebody tell me the difference between reactive and proactive? What's the difference between reactive and proactive? Yes, what's the meaning of these two words? Reactive and proactive. Anyone? You can type it or open your mic. Opening mic is usually faster. Yes, anyone? What is the meaning of, what is the difference between being reactive and proactive? Yeah, reactive and proactive. Who knows the meaning? Yes, please go ahead. Hmm. Yes, yes. So in your design, you have to you have to take a proactive approach. For example, in road design, I give the example of the pedestrian crossing. So when you were designing the signal, you did not take into account the elderly pedestrian. and then some accidents happened, and then now you will go and change the signal timing. That's a reactive approach. The proactive approach is, before the accident happened, you already considered all the different types of people who will use the signal, and you design the timing according to that. Okay. uh, this is a proactive approach. So in your design you have to be proactive, and your proactiveness will affect the people for many years, decades. Okay. So decisions which you make today will affect resource consumption. So these are like immediate effects. Okay. Immediate effects. So you may go for material which is more expensive. You may go for a design which needs more material. Okay. You may harm the environment. You may not feel it immediately, but the environmental impact starts with the project itself. Yeah, people feel it maybe after 10-20 years. Oh, because of this road the pollution has increased, or because of this building the area is not looking good, or because of this pipeline we had soil pollution in the area, we are dumping the waste here, so now we have start to have smell, and we have bacteria, and we have disease in the area. So you may feel it after some years, but environmental impact, as you would agree, happens immediately when you are doing that thing, right? It starts to happen. And then we have public safety and community welfare. I already gave the example, signal, ramps, whatever. So it will start to affect the community immediately. Okay, so and it will keep on affecting them for many years, as I said earlier. And in the long term, your design may have premature failure. So you are designed for 50 years, 60 years, okay, but you did not take into consideration, for example, the changing weather. Okay. When rain happened, your design failed. Okay, because you did not consider the changes in the weather conditions. Okay, or you did not consider the let's say you were like me, you came from another country and you designed something for Bahrain. Okay, so you did not consider the weather of Bahrain at all. You said, okay, this type of thing works in Pakistan, or works in India, works in wherever. Okay, so it should work here as well. Okay, so now the environment is different, the weather is different. Your design may fail when it is exposed to these weather conditions. Okay, so this is what we call as premature failure. Okay, the design fails, the project fails before the end of the design life. Okay, obviously all projects are supposed to end at some point of time. Okay, nothing is indefinite, right? Nothing is infinite. Only Allah is infinite, right? So everything, including ourselves, we are supposed to have a lifetime. Okay, so premature failure doesn't mean that something ended. So things, projects, buildings, roads, they are supposed to end. Okay, but we have a life cycle in our mind when we design them. Okay, so premature failure means when you do not fulfill the life cycle. That's what we mean. Okay, the other thing is, yeah, it did not fail, but it requires high maintenance costs to fulfill its purpose. Okay, so yes, there's the building. The building is not collapsing. Okay, but you start to see the cracks, and you start to see the leakage of water, and you start to see other problems in it. So yes, building is not collapsing, but at the same time it is not usable as well. People will not like to live in such a building. Okay, so in order to continue with the operation of the building, you need high maintenance costs. Okay, same thing with the roads. So yes, there's the road, but that road has cracks and holes and whatnot. So yes, I can drive my car on that road as well. Okay, I can drive my car even when there's no road, right? But is this the correct definition of a fully functional road? No. So in order to make it fully functional, I have to do maintenance. Okay, again, you need to keep in mind that maintenance will always be there. Maintenance will always be there. It's like your car. Okay, so you do regular maintenance like change of oil, change of tires, okay, and cleaning and whatnot. This is regular maintenance. Okay, you have to do it. There's no escape from it. But there's other types of maintenance. Okay, where you go to the garage and you keep your car there for days and the car will not work if you don't do this. So this type of maintenance. Okay, so a car is good when the second type of maintenance is less required or it is cheaper. Okay, so the other type of maintenance which everybody is doing on regular basis is, we are not talking about that. Okay, same thing with the construction projects as well. Okay, so yes, building will require some repainting after maybe 4 or 5 years. It may require some other type of maintenance once in a while. That's normal. Okay, we are talking about other type of maintenance where the building is not no longer usable until you do this. So that other type of maintenance needs to be less, and this needs to be long lasting as well. Okay, so because we are talking about infrastructure projects, so whatever decisions you will take, it may harm the environment and the society. Okay, because your projects are in the open. Okay, and they are accessible to everybody. Okay, so building, for example, so anybody who is passing the building, going into the building, it's open for them, right? So civil engineering projects are not restricted. Okay, so and this is why we are saying we should serve the communities equitably and should provide access to everybody and so on and so forth. Okay, because our projects are not restricted. Yes, we can say this building is for this use, this road is for this use, but you cannot restrict it that only these people will use it and these people will not use it. Okay, it's like phones or laptops. Okay, so only the person who will buy is supposed to use it. Okay, it's not like I'm sitting with you, so I will use your laptop and I will use your phone. It's not like this. Okay, so you have your own choice. And the company can say, okay, this phone is specially designed for blind people and so on and so forth. Okay, so others will not buy it. But the same thing is not true for roads and buildings and water pipelines and electricity pipelines. Okay, so you have to look, you have to be more careful because your infrastructure is not restricted to a specific type of people. Okay, so in summary, a civil engineer, a sustainable civil engineering design has to be safe, it has to be economical, and the civil engineer needs to feel responsible for everybody. Okay, and not for only present but also for future generations as well. And in the current scenario, okay, sustainability is not an option. Sustainability, we have discussed many things. Okay, so and there's one aspect in which I said you cannot negotiate on it. Which aspect was that? Somebody remembers? Which aspect was that? I said you cannot negotiate on this aspect. We discussed in the slides today. I believe the first slide. Which was the aspect in which I said you cannot negotiate. You don't have an option. Okay, should I do this? Should I don't do this? Which aspect was that? Yes, anyone? Which aspect of the design was non-negotiable? You cannot, like, you don't have any option for it. Safety, yes. Okay, safety. So safety is part of sustainability. Okay, so you have to make sure that you maintain safety and health and other aspects so of sustainability, and it's not an option like it's mentioned here. Okay, they're using the term here that sustainability does not mean being green only. Okay, so sustainability has a lot of things attached to it. Okay, durability is one of them, low maintenance is another one of them. Okay, so maybe you can increase the environmental sustainability of something by using a material which is less harmful for the environment, but it will not be durable. I gave the example of concrete. Okay, why we use so much concrete? The concrete is durable. It can last for many years. Okay. If I replace concrete with something else, and that material could be more friendly, environmental friendly, but not be that durable. So it will have more maintenance cost, it will have a less lifetime and so on. Okay, so sustainability is not just looking at one aspect, it's the whole design philosophy. Your whole design should revolve around it. It's not like you do everything as you want and then in the end, okay, I will add a ramp. No, the whole design has to include sustainability from different aspects, environmental, from economic, from social, and so on. Okay, it is our professional responsibility. Okay, so you cannot run away from it. Something which is your responsibility, you cannot run away from it. You cannot say, I will do it or I may not do it. There's no option for you. Okay, it's the main engineering constraint. Okay, so it goes hand in hand with safety and cost. Okay, so constraint is something which sets the limits for you. Okay, constraint means something which will tell you what is your limit. Okay, you cannot go beyond this boundary. So this is called as constraint. Okay, so sustainability gives or provides you the boundaries within which you have to work. Okay, so I already gave you the example. You cannot do something which will be harmful for the environment. You cannot do something which will be harmful for the people. It will have accidents, and it will degrade the quality of life and so on and so forth. So it sustainability tells you what you cannot do, basically. Okay, and as I said, you have to keep in mind for the whole design. Okay. This is class activity. We need to understand the main outcome of the activity is you need to understand how engineering decisions are made. Okay, so the activity is that you have a small public building in Bahrain. Okay, you have two options. You can choose between standard materials with high energy consumption, or you can choose energy efficient materials with better insulation. Okay, so now for each of the options you identify two environmental impacts for each of the options. It could be positive, it could be negative. Okay, it could be positive, it could be negative. So what I will do is I will open the discussion in the blackboard. Okay, each one of you will go there. You will post three things. Yes, two environmental impacts of the first option, two environmental impacts of the second option. As I said, it could be positive or negative, and you will give your decision in the end. Okay, which option is better. Okay, and you have to provide with the reason. Okay, so each one of you will post two environmental impacts of the first option, two of the second option, and in the end your decision to choose which one. Okay, so I'll open the discussion in the blackboard, and each one of you will do it on their own. I'll move on. This is another one. Okay, so this is related to the life cycle cost. Okay, and we do not focus just on the construction cost. So activity, a road is being designed in Bahrain. We can go for a thin pavement with low initial cost, or a thicker pavement which has high initial cost but longer life. Okay, let us not do it on blackboard. We will take more time. I'll just ask you on the Teams. Okay, you can type on the Teams. So I need you to give me first of all which option you will design, which option is more economically sustainable. Okay, and why. Okay, I'll make it simple. Okay, so just focus on on one question. Which option is more economically sustainable and why? Just do it over here. Yes, I'll show you the options again. Option A is thin pavement, less initial cost. You have a thicker pavement, high initial cost, but longer life. Yes. Okay, good enough. So, okay, so I believe it's better to do it here, but anyways, another one should, and this is about public safety, equity, and quality of life. A new road is built without pedestrian crossing or facilities. Okay, so there are no sidewalks, there are no crossings. Okay, uh, so you have to answer. Now the question is slightly tricky. Okay, so I will write the question in teams. Okay, so a road is designed without pedestrian facilities. What benefits will we get from this design? Number one. Okay, and which people are getting harmed because of it? Yes. So the okay, you can later on look at the questions in the slides and you can answer them and show them to me. But for now, for the sake of the class, if a road is built without any pedestrian facilities, so we are saying that what benefits, like why did I do that in the first reason, in the first place? Okay, so now you have to look from the other aspect as well. If somebody is doing something which looks not sustainable, why would somebody do it? So why would somebody design a road which does not have any pedestrian facilities? What could be the reason? Okay, and when he did that design, he's harming which type of people? Okay, so this is a scenario. If forget about the question is on team. Yes, go ahead. Good. Okay, I will give you one more reason as well for not designing it for the pedestrians. Some roads are very high speed. So those roads are not designed for pedestrian crossings, okay, or with pedestrian facilities, because we don't want pedestrians to cross them or even be on the side of the road because of the high speeds. Okay, this is like something technical. Obviously, you cannot know this, but yes, you have already mentioned the things which are very obvious: the cost, more work. Okay, same saving space, electricity, carbon emissions. Yes, all of these things are true. Okay, so okay, now this is a group task. Okay, so I will divide you into groups now. Okay, I have how many people? I have 26 people. Okay, I will divide you into groups. Okay, you are doing it online, so don't say okay, boys separate and girls separate. Okay, I will just do it randomly. Okay, so you will go into separate rooms. Okay, like here. Okay, on Teams, and you can discuss through messages. So each one will be in a separate call. Like, okay, and the thing which I have to discuss is this one. If somebody can take a screenshot, maybe. Okay, or I don't know, can I put it here? Let me see. Here. So I will put it here. So in your group you will pick uh, a specific infrastructure project, road, building, water. Okay, and you have to, for this project, you will list down or you will indicate how environmental, economic, and social sustainability can be considered in this project. I'm not looking for design, but what are the aspects? Okay, for example, for roads we talked about pedestrians and we talked about weather or whatever. Okay, so you just point out the aspects. Okay, so in the group discuss which type of project, and then you discuss these aspects. Okay, so I will divide you into groups. I'll move on. So I want to finish this. Okay, so inshallah the attendance will be fast. I will be taking it on app, so I don't have to like, switch screens again and again. So the point is, you have to consider, as I mentioned, sustainability is not just a component; it's an entire philosophy, and you have to consider during the whole life cycle of the project. So from the planning stage, it starts with site selection. Okay, now in many cases we don't have the choice for site selection. Okay, so I'm constructing a building or I'm constructing a villa for myself. I don't have the choice for site selection. Okay, but if I'm doing it for a government project, a new road, a new bridge, a new pipeline, a new water treatment system, a new electricity production unit, then I have the choice of site selection as well. Okay, and whatever site you select, in many projects, especially big projects like malls and so on, even if a private consultant, if a private owner is doing it, they will be required to do an environmental impact assessment. Okay, even a private owner has to do an environmental impact assessment. So he has to show what are the environmental impacts of the project. He cannot change the site. Keep in mind, obviously, he will use his own land. So he will show to the government what are the environmental impacts of the project and what he will do to minimize them. Okay, so from the planning stage, your sustainability considerations start. Then in the design, many of you already mentioned the point of energy, the point of material, and the point of not yeah, somebody mentioned heat waves, for example. So that's part of resilience. Okay, when something happens which is not part of normal operations. Okay, a heat wave, a dust storm, a very heavy rain. Okay, an earthquake. Okay, so that uh, that tests the resilience of the structure. Okay, so you need to keep in mind that there will be extra or unforeseen risks. Okay, so you need to keep it in mind as well and consider it for your design. During construction, you have to reduce the wastage. One of the things which we do for reducing the waste is using precast concrete. So they make the concrete slab and the beams in the factory. Okay, or they do the mixing through the mixers. If you have seen the mixers, they are mixing and moving. Okay, so these type of steps, they reduce wastage on the site. Okay, they reduce wastage on the site. Use efficient methods which will have less cost, which will be done faster. Okay, I already gave you the examples of these methods with precast. During the operation and maintenance of the building, make sure you are using less energy, lower energy. So use appliances which require less energy. Okay, so we know somebody when we are doing the physical classes, somebody mentioned the LED lights. Okay, so why LED lights are more used? Because they consume less energy. Okay, and use things which have easy repairs. Okay, so I don't have to like break the whole ceiling for repairing a wire, for example. Okay, use things which can be easily repaired. Even if you have to replace them, it can be done easily. At the end of the life, so you also have to think, when the life ends, what will I do with this total project? Okay, so there's a building. Okay, the building was designed for 50 years. Now it did 10 more years extra. Okay, but now this is the end of the life. So what should be done? Okay, I will demolish the building, I'll bring the new one, but what can I do with the demolished building? Okay, can I use this material somewhere else? Can I use how can I reduce the waste from this building when I demolish it? Okay, what are the things which I can reuse? What are the things which I can recycle? Okay, so there are two things here. One is the reuse, the other one is the recycle. Reuse means you use it as it is. Okay, so just like your phone charger, you have a phone charger from your old phone, and you bought a new phone, the charger still works, you reuse it. Okay, this is a reuse. Recycling is, okay, the charger doesn't work, okay, but the charger has a connector, okay, from which I can just cut off the pin and the end, and I can put something else and do something else with it, and so on and so forth. That is recycling. Okay, so somebody was writing on a paper, you took that paper and you erased what was on it. This is reuse. Recycle is you take that paper, you shred it, and then you make something else with it. This is recycling. Okay, so the difference between reuse and recycling. In reuse, you use it as it is. Recycling, you have to do something else with it, like you are making it into something else. Okay, so you have to think the material which I've used in the building, the things which I've used in the building, how many of them can be reused, how many of them can be recycled. For example, aggregates, they can be reused maybe, okay, as it is. You put it in another concrete, but steel you may have to recycle, plastic you may have to recycle. Okay, and when you do this, when you take care of reuse and recycling, you will have minimal waste. So sustainability is a long-term responsibility. You have to think till even what will happen after the project ends. Okay, sustainability has a connection with ethics as well. Okay, so it's an ethical responsibility, ethical obligation. Okay, not a technical choice, as we have said it a couple of times. So we will discuss ethics later on, but ethics is something which you have to do because of your personal duty. So there's a professional duty and there's a personal duty. So ethics is part of your personal duty. I have to do it as a human being, okay, not just an engineer. So everybody has ethical responsibilities, but everybody doesn't have the professional responsibilities. Okay, so for example, labor on the site. The labor doesn't have a technical professional responsibility, but he still has ethical responsibility. He still has ethical obligation. Okay, so he cannot leave his tools on the walkway, for example. That is unethical, right? And he cannot just throw garbage on the road. Okay, that is ethical obligation, ethical responsibility. Okay, so ethical is what you have to do personally, not as a professional, but as a human being. So that's why we keep on saying sustainability is not a choice, because this is your ethical responsibility. I'm not doing it as part of my engineering. I'm doing it because I'm a human being. I have to take care of other human beings. Okay, so you as a civil engineer, you must protect health and safety. Okay, if you see something is harming the other people, something is harming other people, you have to take care of it. Okay, whether you are labor, whether you are engineer, whether you are the boss, whether you are the client or the government, you have to take care of it. Okay, using resources, unnecessary harm to the environment, same thing. It also affects health and safety. Using resources responsibly. Okay, so even when you are at home, you cannot switch on all the lights and switch on all the ACs throughout the day. You are wasting national resources. Okay, so it has nothing to do with your engineering. Okay, so same thing happens in the now when you are an engineer, you just have to look at it from a different perspective. Okay, but the responsibility is still the same. You have to save the resources, and you have to look at the long term societal impacts as well. Okay, so if you ignore these things, you will cause environmental damage. You will have unsafe infrastructure. Unsafe infrastructure, I already gave the example of the accident of the pedestrians. Okay, you may have couple of accidents and then you know there's a problem. Okay, and obviously that will be very costly. Human life is costly. Okay, and then if you try to correct your mistake, it will be costly for the public as well. Okay, and it will burden the future generations. Okay, uh, and then we have, so each of these topics we have a separate set of slides for them. We are just going through them quickly here. Okay, so engineers have professional expectations. We have talked about ethics. Okay, I believe I should stop here. I'll stop here. Okay,